Hey guys, Mr. Klein here, and you're probably aware that the Centers for Disease Control has recommended that people wear masks in public. So before we start talking about masks, we need to understand how airborne diseases spread. So many diseases transmit themselves through the air. So it's either directly from person to person or actually just landing on the surface to be picked up by a person later. So these diseases are caused by pathogens, viruses, bacteria, things like that. And they're really small. For instance, E. coli bacteria is about what we call 1 micron in diameter. Viruses like SARS-CoV-2, COVID-19, is about 0.13 microns in diameter. And just for comparison, the average human hair is 50 microns in diameter. So there's two ways that these pathogens travel through the air. The first is that they float through the air either on their own or they're stuck to really tiny dust particles. A good example of this would actually be the flu or the influenza virus. Most diseases have trouble being transmitted through the air alone in this manner, and if they don't reach another person in time, they're going to die. The other method involves the pathogen sticking to larger particles, usually water particles that emanate from the lungs, which then float through the air. So these tiny particles and these tiny droplets, we call them aerosols, and for the pathogen, being aerosolized is a way more efficient method of transmission. The reason is the water allows the pathogens to live in there and survive longer outside the body. The downside of this is because these droplets are heavier than dust or the pathogens themselves, they don't get to travel as far. Great for us because it's easier to dodge a sneeze, not so great for a pathogen to survive in the long term. So what's the big deal with masks anyway? Well, there is a misconception we need to clear up here first. The idea of wearing a mask, this recommendation, is not to actually protect you from germs or particles floating around. Rather, it's the other way around. So for instance, you may be asymptomatic. In other words, you're sick, but you're not really showing any symptoms, so you don't actually know you're sick. And as a result, you're spreading like the virus or the bacteria to other people completely unaware. In Asian countries, masks are really common because of air pollution in countries like China, but also it's a social thing. It's due to the idea that it's polite not to spread disease, especially in cities with massive population densities like Tokyo or Seoul. So in other words, wearing a mask is not to protect you from other people, but is rather to protect other people from you. So what happens is when enough people wear a mask, you're preventing the pathogens of a disease from spreading. If enough people do that, the reproduction factor of a disease, we call this sometimes R0, drops so low that the outbreak tends to die out. So if you want to know about the exact mechanics of when pandemics die out, you can watch my video on how pandemics end to learn more about that. Also, you might see things like this called a respirator instead of a mask, and you might be wondering what's the difference between this and what's the difference between this. Well, first off, the mask and a respirator have fundamentally different ways of working. A mask is actually pretty obvious. It covers the face, It's designed actually just to be a simple barrier against particles, splashes, or aerosols like from a sneeze. So because a mask fits really loosely around the face, it doesn't have a seal, so it doesn't provide total protection from particles and gases. Cloth masks provide minimum protection, but surgical masks provide better protection than cloth masks do because the material that they use is specifically made to block particles from passing through them. Respirators, on the other hand, are designed to protect the wearer from inhaling hazardous substances, such as dust particles or poisonous gases. So in order for it to be effective at this job, it has to form a seal around the face in order to prevent the particles from getting around the filter. In the United States, the National Institute for Occupational Safety and Health, they classify respirators by the percentage of particles 0.3 microns in size or larger than they can block. So the three levels that they use are 95%, 99%, and 99.7%. Though the classification for that last one is known as 100. So the letter next to the number indicates whether the fabric is resistant to oil-based aerosols as well, so like lubricants from machinery that might spray out. So in other words, if you have an N95 mask like this, an N95 mask blocks 95% of all particles 0.3 microns or larger. But the material is not resistant to oil-based aerosols, so you're not going to use them in industrial methods. Other countries have similar standards, so you might see respirators somewhere with FFP2 or KN95. There's small differences between their classifications, but for our purposes, they're practically the same. And one more thing. So an N95 mask is designed to block particles 0.3 microns in diameter. That's about 3 times as big as that of the SARS-CoV-19 virus. So how do masks and respirators protect against the spread of an infection? Well, it comes down to how well the material actually blocks the particles from getting through the mask. So the smaller the gap between mask particles, the better they are at blocking the particles from traveling through there and going outward. So a cloth mask, now this is my wife's by the way, the hearts are totally fine. Its ability to block particles depends on how tightly woven the individual threads are. So if you see a cloth's overall thread count, that's the number of threads within a square inch or centimeter depending on where you are in the world, that will help you figure that out. So the greater the thread count, the more tightly packed the threads are. And you can always check this by taking a cloth and just putting it up to a light. The less light you see, the better it will be at blocking particles passing through them. So for synthetic face coverings like surgical masks, N95 respirators, their ability to block particles improved due to their manufacturing process to create this fabric. So both of them, like I said, are made from synthetic materials. They're plastics, polypropylene, and the individual threads of the material are created through a process that we call melt blowing. Melt blowing is much like the process that a 3D printer works. So what happens is the plastic is melted at an extruder and it comes out in a liquid form through a nozzle. Rather than it being precisely put in place, the liquid plastic is sprayed onto a rotating drum. So this process creates an irregular pattern of fibers that cool down on contact with the drum. So once the sheet is made, it's cut off and the next sheet begins forming. The advantage of melt-blown face coverings over cloth masks is that the individual fibers, because they're being sprayed, they actually land in an irregular pattern. This works really well at blocking things because the result is that as you layer the sheets over each other, the gaps between the fibers in a single layer get covered up by the next layer, either above or below because of the randomness of the threads. So this means that the particles that are trying to pass through will have a much tougher time than it would in a traditional cloth mask. In addition, because the fibers are single strands of plastic, they don't have gaps like the fibers wrapped together into thread in a cloth. So what this means is that there's additional protection in preventing particles from passing through that method as well. So in order to see how effective each of these masks and respirators are at reducing the spread of particles, I decided to test them using Cornelius the foam head. So what I did was this, is I drilled a hole through the head and put a pipe that was close to the size of the mouth, open mouth while sneezing, that began in the mouth and then it traveled and continued out through the back. So the arm of this pipe right here, I used it to pour colored chalk into the tube. Obviously, it's orange from this. And then what I did was I put an air sprayer here in the back to simulate a sneeze, which would generate a puff of air at about the same speed as a normal sneeze, which according to peer-reviewed research is about 150 kilometers per hour or 93 miles per hour. The chalk then sprays out like water droplets would when you sneeze. So it's a reasonable simulation of what you would think would happen. So the first test is a cloth mask. So people have been making these by the thousands used during the COVID-19 pandemic, and you might be wondering, well, how well would they work compared to, surgical masks? So I actually had trouble getting the mask to fit well on Cornelius, mainly because his ears were really flat. So in the test, you can see that a lot of the chalk particles spray upward and out of the mask, but at the same time, the mask itself actually absorbed a good bit of the chalk and didn't allow a lot of chalk to pass through. So in another test I did earlier with a cloth mask, I was able to get a better fit on the head, and you can clearly see that the mask absorbs most of the chalk particles. And while some chalk particles actually go through the mask and outward, the amount going through is much less than with no face covering at all. So in other words, even a cloth mask works really well at mitigating the spread of particles from a sneeze or a cough. So the next test involves the surgical mask. Now, I'm not gonna lie, this test was an utter failure because the ear loops didn't hold on as well as the test. And what ended up happening was the mask popped upward off of the face. This also gives us a really important lesson to take from this test. It's actually the importance of wearing a mask correctly, because if you don't do so, then the mask is all but useless against blocking the spread of germs. So the final test is with an N95 respirator. I had an old one I had lying around for this test and made sure that the respirator was able to fit snug to the face as possible possible using the instructions. The rubber band really helps out with that. So as you can see from this test, the respirator essentially absorbs all of the chalk particles in the sneeze, and with a good bit actually bouncing back onto the face. So in terms of protecting other people from your sneezes, it's definitely the best, and it's not even close. So because of that, it makes sense that the Centers of Disease Control actually recommends that people reserve the purchase of N95 masks for health professionals rather than the general public. So you can see in this image right here the amount of chalk that each mask blocked. The N95 mask, like I said, blocked the most, but the other two masks actually did really well. So the result of this test shows that as long as you're wearing a mask correctly, so you know you're covering your nose, you're covering your mouth, it's fitted really well, you're going to protect other people from whatever germs are carried in your sneeze, your cough, or your breathing. So there you go. Everything you wanted to know about masks and respirators and how they're used to prevent the spread of disease. Remember, the whole purpose of the Centers for Disease Control recommendation is not to use this mask as a barrier to prevent disease from passing through. Rather, it's the other way around. In the off chance that you might be infected with the disease, wearing this slows down the spread of particles which can cause the disease. So it's the whole idea of just being a good neighbor, because after all, you don't want one of your relatives to come down with a disease that could be prevented if you just wore a cheap mask. This has been an episode of Phenomenon Explained, a series of videos that explain how things work in the world around us. This video aligns to the next generation science standards as well as the Louisiana Student Standards for Science. This video discusses 8-MS-PS1-3. And that essentially explains that synthetic materials are created from natural resources, and the purpose of their creation is to benefit society. So if you enjoyed this video, please click on the like button below. If you have any questions, please let me know in the comments below. If you want to see more content like this, make sure you click on the subscribe button, and thanks for watching. 3, 2, 1...